Thank you very much. I'm gonna, since all of you all are over here and you're looking at those screens, I'll step over here. Can you all hear me? You all can hear me okay? Good, okay. I'll have to run over there. I've got one little video kind of in the middle of the presentation here. So I'm Curtly Epperson. I'm the CEO and co-founder of Vigilant Aerospace. I'll give you a real quick background on that. But before I do that, let me ask a couple questions. How many of you all here are pilots? You have pilots that we have to talk to you about their experience? Yeah.
Not current, but it's on the card.
Well, it's a lot of experience to do that. So, and how many of you all have drones ever flown a drone? Have you ever? Okay, good. And how many of you all like to get on an airplane in one city and fly safely and land in another city without running into anything in the meantime? So is that everybody? So that's really what we focus on as a company, is that process. So we're really concerned with air safety, and that's what our product is about. So in the middle of my presentation, I'll have a little bit about our product and a little bit about kind of drone safety and unmanned aircraft regulation generally. Yes?
I was wondering if people didn't mind if we go around and find out who's here and who they represent. I don't know if that would help you too.
Yeah, I mean, that's up to the venue.
Okay, I'll start. My name's Braille James. I'm with Fort Bend Independent School District.
Hello everyone, I'm Hari Chandra. I'm a data analysis engineer.
And I'm primarily with Focus Workforce Board and Workforce Solutions, and I'm our principal economist. So,
Hi, I'm Hassan Al-Bagi. I'm a certified remote pilot.
Hello everyone, I'm Mortada Sapataj. I'm an artist. I do area videos and photos, and I have a license for drone.
Steve Shields, risk management at San Francisco University.
Charlotte Miles, Research and Compliance Administrator with San Francisco University.
I'm Jack Hill in the Office of Research at Sam Houston, and we have a GIS mapping center, and the three of us are on the new drone committee on the campus.
My name is Jiang Gu. I'm with Nielsen. I'm a GIS specialist and landscape architect. We usually use the drone image as a base for rendering images.
My name is Ken Dalton. I'm a freelance journalist here in Houston. I haven't used a drone, but it's becoming a big thing in journalism.
My name is Megan Coughlin. I'm the public outreach manager for the Transportation Department here at the Houston-Galveston area.
Keith Garber, I'm part of the public outreach team, and those few times we get aviation grants, I do aviation planning.
Good. Well, I will customize my talk a little bit on that basis. That's great. How many of you have Part 107? Billy, you have Part 107 licenses? Is that right?
Yes.
I'm our test pilot too, so I have one. And are you here writing for someone?
No, I'm just here for my own identification.
Oh, okay. All right. Well, if you want to do an article about it, okay, good. All right. So I have a lot of material I do want to get through, so I'll go pretty quickly. And I know you all will have questions. Since this is a small group, if you all want to stop me and ask questions, feel free to do that. What I may say is I'll get to that in a moment. And so if I don't get to it, then there'll be more Q&A at the end as well, and you can ask me again until you're satisfied. So, but feel free if you do want to ask questions. So this is what we're going to cover really quickly. We're going to talk about the company and me real quickly so you know why I'm here. We're going to talk about what the market looks like. The market is growing really rapidly, and this is something that we get a lot of interest in, kind of what it looks like and why it's so important. Technical capabilities and applications, and a real quick overview of how people are using drones, why they're using drones, current regulations to fly. Get a ton of questions about this. This is something we're very involved in. We serve on committees and we talk to people a lot, and we provide advising to our customers about how to fit our system into their waivers, for example, that they have to apply for to do certain things with their aircraft. We'll talk about safety and detect and avoid, which is really the core service that our company provides. We'll talk about one case study, just a company that's flying and what they're doing, and then talk about some future trends, and then have a little bit of time for Q&A. So I'm going to go pretty quickly. If you have a question, do stop me and I'll elaborate on something. So we're Vigilant Aerospace, early stage technology company, kind of a classic early stage tech company, founded in 2015. We've exclusively licensed NASA's detect and avoid system, which is primarily a piece of software, algorithms, processes. It has a patent behind a lot of it. And that patent has been issued The commercial product is called Flight Horizon, so I'll talk about Flight Horizon. That's our commercialization of that NASA prototype system that we've built. It's all about autonomous detect and avoid, with the idea being that the software provides the ability both to give information to an unmanned pilot or directly to an autopilot on the aircraft to detect where an aircraft is, where it's going to be, and to go around that aircraft, usually by going under it. There are 12 different strategies the system can use to be sure that it deconflicts, particularly if there are multiple aircraft involved in the airspace. And that's really fundamentally what it does. That's the core thing that we do that is unique. Helps meet FAA requirements. It's been through years of flight testing, including on this very large aircraft, which is not typical. But that's NASA's research aircraft called the Icona, which is a modified Predator. And there's a very large growing demand that we're seeing right now. So that's a little background on the company and where we come from. I am a software person. I've been building software companies for a long time, and my primary interest is in really practical application of software. Background with a GIS company, which is it's always fun to have GIS people, because there's a lot of overlap, obviously, between drones and GIS. And have been on the board of the Houston Angel Network doing investment in other early stage companies as well. Okay, so I'm going to talk a little bit about what the market looks like for drones. So right now, there's about 1.9 million drones, mostly smaller drones, but I'll talk about that mix. The FAA, which does a lot of publication and economic work on the aerospace industry, predicts that by 2020 there's going to be about 4.3 million drones in the US. And among the commercial ones, it's about 600,000 now. Not all of them are registered or in use yet, but it's a drone that is intended for commercial use, growing to about 2.7 million drones in the airspace by 2020. And interestingly, they've just released some new numbers. In March, they said they had 800,000 registered unmanned aircraft. So a large number. That includes, obviously, a lot of hobby drones. And then they had about 42,000 registered licensed commercial, so Part 107 pilots and 333 exemption holders, which I'll talk about what those are. But those are different types of unmanned license holders. By 2021, they expect that to be 422,000. And that probably will represent multiple commercial drones per pilot. So at least one and maybe multiples, depending on what happens. Another interesting study that came out recently was PricewaterhouseCoopers released a study just a couple months ago that they expect that about $127 billion worth of services of various kinds per year are likely to be performed by drones. And so it's a pretty broad swath, and you can kind of look at the details of the study. I have a little bit more information later, but it's a very interesting thing that they expect drones to impact a huge number of industries. So talking a little bit about the commercial side, you can see these numbers here in terms of the total number of aircraft, and it is in the many millions by 2020, and it grows every year. Just specifically on commercial, because that's what my company focuses on, we're expecting that there to be about 500,000 by 2020 in the airspace, and that really is including drones that are very, very capable. They can go long distances. They carry a payload that's for a specific purpose. That excludes the hobby drones. Those are real commercial drones that are doing real work. So it's expected to grow quickly, and this is all based on FAA work. Some people call the FAA high on their estimates. Some people call them low. Typically, what we've seen every time the FAA does another one of these estimates, as it does about every year, the numbers keep going up, and that's based on their actual experience. They expect actually the numbers will go up quite a lot as the regulations become looser, and you can do more with drones. So right now, this is a current estimate of where drones are mostly going to be used. And particularly in Houston, of course, I think industrial inspection is an important topic. Agriculture is very important. Insurance, that includes a lot of things like inspections after storms, claims validation and management, all that kind of stuff. Real estate photography has been the dominant use of drones up to this point, because when you're doing what's called within visual line of sight, it's very easy and quick to get great real estate photos, and so a huge amount of drones used for that. But we expect that's going to change really rapidly, because larger, longer range drones, more powerful drones are coming out that can really do industrial work. So this is a little more detail on this PricewaterhouseCoopers study. I won't spend a long time on this, but infrastructure is expected to be impacted to the tune of about $45 billion per year in services. And that's just one area. Transport, $13 billion. this is a study that's having a lot of impact now because people are beginning to realize that drones really are going to infiltrate all these industries and be used a lot. Okay, so I'm going to go on and talk about technical capabilities. Before I do that, I will pause if there are any questions kind of about the marketplace or any market trends. Yeah?
How much is a whole lot, what percentage is international where there's less FAA rules and what percentage is US when you put these numbers down?
Those numbers are all US numbers.
Oh.
None of those are international. The international rules are very different, and we do have a lot of people approaching us internationally because you can do a lot more with drones right now in a lot of other countries than you can in the US. And if you talk to the FAA, they'll explain the US has the most complex airspace, the busiest airspace in the world, and the safest airspace in the world. And they want to keep it that way. They don't want to restrict people's ability to fly their planes because they're introducing unmanned vehicles. And they also don't want to lower the safety of the overall airspace. And that's one of the reasons that the FAA, of course, is taking their time. We'll talk about regulations a little bit. But we have people from the UK, France, European Union, Indonesia, China, Japan, South Africa, Botswana, several other countries where they do have different civil air aviation authorities that allow them to do a lot of stuff you can't do in the US. There's a lot of wildlife monitoring, a lot of really cool stuff, actually.
And the other question is the application in agriculture. I can see where you fly and see where there's weeds or fertilizer needs, but to fix it, you need a crop duster or somebody to spray chemicals or do something. I just don't understand I can see the mapping, but then to solve the problem is on the ground or something.
So that's the next slide. So I'll talk about that a little bit. It's very top of the list. It's agriculture. It kind of comes and goes in whether everybody thinks agriculture is the killer application for drones. I think the consensus right now is it is. And the thing that's interesting, if you look at this little map here, for example, and I've got a few other little maps like this, if you go online, you can see thousands of them. Primarily what drones are being used for with multispectral cameras, where you're looking at infrared and other things to figure out what's going on with your crop, is they're figuring out where they're underwatering, where they're overwatering, and they're figuring out where they're under-fertilizing and over-fertilizing. And they're primarily doing that. The drone doesn't respond to any of that. What it allows them to do is to stop doing that, right? So they can stop watering one place and then water sufficiently somewhere else. And the crop yields go up where you shift resources primarily, or you bring in fertilizer where you haven't sufficiently fertilized. So that's really what they use it for. And it's being used a lot for that. It's pretty much as a service. You can call somebody, they'll come out, and they'll give you a report, and they'll give you a map, and they'll say, this is what you need to do. And so it's reached that level of sophistication now. And imagine applying that to dozens of other industries. So agriculture, it's kind of an obvious use, but it's got to be pretty low cost. Like those people don't charge a lot for that service, even if you're a large agribusiness. You can buy those reports pretty cheaply, and you can optimize your fields really effectively. And I think that's just going to get better year after year. Other places it's being used is in mining, particularly where they're trying to control facilities and theft. There's a lot of that. Drones are used for patrolling. And there's also a lot of safety. Oil fields, tanks, pipelines. Primarily you're looking for leaks. You're using either multispectral cameras, or some people are even starting to do gas detection devices on the drones, so you can really monitor a large space very, very quickly. One of the big advantages is not that you're looking for something different than you would otherwise look for on your pipeline or at your refinery or at your tanks. It's that you can do it much more often, much more frequently, much higher precision, because you can basically take the time to hover over all of your assets, collect the data, and you can do it almost daily. So that's really going to have a big impact on the ability to detect leaks much earlier. And that's a big issue, obviously. All types of infrastructure and asset monitoring. So if you're looking at electrical lines, you're looking at water pipelines, drainage systems. So we have companies that monitor citywide drainage systems that include a mix of rivers and man-made drainage. And we've also talked to the people in Northern California around the dams up there that they've had some real problems with in the last year. They're walking a lot of those dams. They have fire departments in Northern California that are, as fast as they can, they walk those dams because they're trying to avoid another Hornbill kind of situation where you're threatening an entire city and hundreds of thousands of people with a dam or a levee breaking. And so they're actively trying to figure out how to use drones to monitor and manage that. And they estimate with just a few drones, 3 or 4, that they could do most of Northern California every day or two, which is a huge improvement from literally having firefighters, rather than fighting fires, walking on dams and walking on levees, which is what they're doing right now. So we've had some really interesting discussions with people in Northern California. And then roads and bridges. I mean, it seems pretty obvious, but you know, a lot of rural bridges and roads don't get looked at as often as they should, particularly there are places that are difficult to get to. And going back a little bit, there are a lot of tanks and other things, whether water or other fluids are being stored. Some of those jobs are quite dangerous. These are industries that have, you know, a lot of concern about safety. They know how many people are injured and killed every year doing these jobs. And so they're trying to reduce that number because it's a huge cost and a huge waste to do this kind of inspection, and yet it's absolutely critical that they do it. So drones just offer a great solution for that. So we're really excited about that. So that's where we start with the applications. So I'll go real quickly here. These things are mostly around manpower, keeping aircraft in the air, which is very expensive, and then the inability to do certain types of critical inspections as frequently as what your infrastructure actually requires and demands, right? You just don't have the manpower and time to do it. Some of the case studies indicate that doing it with a drone can be up to 90% less expensive and less time consuming. And most of the time it's a time is money kind of situation, exactly, although obviously flying a drone is usually less expensive than an aircraft. That equation is still balancing out right now because typically with your aircraft, you keep it in the air for a shorter period of time than you would a manned aircraft. But very soon that's going to change so that your unmanned aircraft can stay in the air as long as a typical manned aircraft. And this equation will get even better than it is now. So we're really excited about that too. All right, so I'm going to talk a little bit about some of the most exciting things going on with current capabilities, and then we'll talk about future trends at the end of the presentation. We talked a little bit about using drones in agriculture. These sorts of multispectral cameras that can see into the infrared and then the data power to sort of do something with that are getting better all the time. They're getting to the point that you really can go buy a very inexpensive $1,500 drone, more or less, put one of these cameras on it for another $1,000, $2,000. These used to be $100,000 minimum, these types of infrared cameras, but they're now very inexpensive. And you can go do a field. So you do have a time limit. The smaller drones don't go for a very long distance, but if you upgrade to a drone that's got an engine in it, burns gasoline, you can do many fields in a matter of a few hours with one of these cameras. The other thing that's really interesting, of course, that some of you may have run into is LiDAR. Putting a LiDAR unit onto a drone now is much less expensive than it used to be. They're coming down in price all the time, and they're very powerful even on the small. So this is like a Matrice 100, I think it might be a 600. But that's a DJI drone that you can really just mail order. They range in price from a few $1,000s to about $25,000 for these. And then you put one of those units on it and you can go map your infrastructure. And LiDAR uses lasers to create what's called a point cloud, so you get detailed 3D images and detailed 3D models of your asset or infrastructure. So it's great for figuring out where stuff is, whether it was built correctly, whether it's deteriorating, great for figuring out new things that have been built and just looking at the airspace around those things. The other thing that's happening really quickly is the services to support what you do with all this data after you collect it or emerging. Drone Deploy is a big one. That's the item on the left there is one of their applications. But everything's being moved to the cloud, and in fact, it's getting to a point where as soon as you take it, it's pretty much being uploaded, if possible. If not, when you get back to the office, it'll upload automatically. And then all the tools are there and available and pretty easy to use to do something with the data. So there's a lot of companies that are really, really working on that. The other thing that we're really excited about, because some of our clients are really using these, are the emergence of what we call hybrid drones. So these are UAS that take off and land vertically, but fly with a fixed wing model horizontally. And that gives them a huge amount of efficiency. They can go really long distances with a really good payload that you can launch them from anywhere. And that's been a huge restriction up until a couple of years ago when several companies came out with these drones, where you can take them off from an oil and gas platform, you can take them off, as I did recently, from a beach and go do a marine offshore patrol, and then come back and land right on the beach. So no requirement for a runway, which is a really big deal for the fixed wings. The other thing is just the emergence of more and more bandwidth. The stuff available that you can just buy off the shelf to do 9 to 10 miles of real-time live communications with video and other data coming off your drone has changed a lot over the last 2-3 years. And then, of course, you've got satellite communications, which are obviously more expensive, but allow you to do really amazing things. So when we work with NASA, they've got access to all the toys. But the thing that's on the right, the thing from NASA. The thing on the left is something you can buy. It's a Silvus radio unit that'll go many, many miles and give you real-time data. Those are what a lot of our clients are starting to use. Okay, so I'm going to talk real quickly about regulations. This is an area we tend to get a lot of questions. It's an area where things are changing really rapidly, and it's really exciting right now. I'm going to talk about the main 2 ways that you can fly, which were 333 exemptions in Part 107. And some of you already know a lot about Part 107, obviously. I'm talking about some new trends with the FAA, what the kind of rules that it's creating and likely to publish in the next 6 to 18 months. They've got several committees that are making rules, and those are going to be published. There's a lot of pressure on those committees to get those rules published. And then the FAA's new Re-Authorization bill in Congress was released. I think it was kind of leaked, and then everybody started reporting on it. So there's a draft of that bill that has some very interesting things in it that people in the drone industry like me are very excited about. So I'll talk a little bit about those trends. So the first thing I'm going to talk about is how you fly. So does anybody know what a 333 exemption is? So before August of last year, 2016, the only way to really commercially fly a drone was with what's called a 333 exemption, which allowed a pilot, a full pilot's license, to fly a drone. And the 333 exemption said you could fly it remotely. Okay, so that's how you did it. It was expensive. It was cumbersome. You had to do a lot of work for compliance. It was regulated like an airplane. You had a gate number on your aircraft. And there were some cool things about it, though. You could get a certificate of authorization to do a lot of different types of flights, and particularly public sector entities. So sheriff's office, fire departments, Department of Interior here in the U.S. were getting certificate of authority from the FAA to do types of flights that you can't really do commercially yet, and they were kind of pioneering this space. You could also get emergency beyond visual line of sight for response to things like wildfires. Very rare for a limited number of days, but it was done. And so that was great stuff. But what was really exciting is in August of last year, Part 107 came into force. It had been passed earlier. And the result is that Part 107 allows anyone to go get a license to become a commercial unmanned pilot. And as long as they follow a strict set of rules around that, they can fly for money. And they can do almost anything with that aircraft. There are rules about where and how you can fly, but generally you can do whatever you want to with it. So all of these applications I was talking about, all of those are available with the Part 107. You can even deliver stuff, but you can only do it with the line of sight. So some of the restrictions on Part 107, and this is whenever people talk about drones right now and why they're excited about it, it's mostly because of Part 107. So this is this new law that allows anybody to go do this commercially. So you get your license. It has to be under 55 pounds. So that is a limitation, but it's amazing what you can do under 55 pounds. You can fly commercially. You can get night waivers. I say night waivers. I changed that at the last minute. But anyway, you can do night waivers, so you can actually fly at night. That's quite popular. People are recording concerts, festivals, all kinds of stuff, monitoring farms and ranches. And you can get a waiver to fly beyond line of sight very soon, we think. And I'll talk a little more about that. Yeah?
Just mentioning filming concerts and stuff like that. Aren't operators not supposed to go over crowds or supposed to wait for that?
Yeah, so typically what they're going to do is they're going to fly in a space where there aren't any people directly under them. So you can take pictures of people at a concert all day long. You just can't have them under you. Okay? So what they'll typically do is they'll be to the side. And if you go online and you're a part of groups that are discussing these things, pilots who don't follow those rules get in a lot of trouble with the community. People get really mad, and they ask that person not to fly again if they fly over people. But if you know what you're doing, and I know a lot of people that do this commercially, they are either they'll do it freelance or they'll do it for the organization, and you fly to the side of those people. And sometimes there's even a designated area people are not supposed to go. You can fly over people that are your crew. So if you have people that are helping you, that are involved in doing something with it, you can absolutely fly over them. CNN actually has a waiver to fly over uninvolved people. They're the only ones that have it. They just got it. That's not true. There's another organization that's developing micro-military drones that also has that waiver. But that's because their drones are like that big. So you fly over somebody, you're not going to hurt anybody. CNN has the right to do it with larger drones, but they're the only people that do. And it's because they've been doing it for years, and it's kind of an experiment. So the whole FAA waiver process is very experimental, and if you read the 600-page document that they published with Part 107, it goes into detail about what their process is. And so what they're trying to do is they're trying to have enough people take out these waivers, which are issued on a one-by-one basis for pilot aircraft and mission, and essentially for a period of time usually, although it used to be a few days, and now you get it for years. And get enough data into their process and their regulatory process that they feel comfortable and confident that they can give that waiver to lots of people, and in fact change the law and the regulation. And so that's really what they're actively doing. So they're actively, trying to get companies to take these waivers out with exactly the right equipment, the right experience, and the right mission to encourage this kind of development. So yeah, but flying over people is a big no-no generally.
Red hats.
It does happen, and really it's one of the things that people get in the most trouble for. Like if you're going to have local law enforcement getting mad at you, it's for doing that usually. Okay, so I talked a little bit about Part 107. That's really what everybody gets most excited about. The one thing I'll mention is the FAA gets criticized sometimes because it doesn't move very fast on some of these regulations, and we're behind other countries, and we feel like we're developing much more slowly than Canada, Mexico, China, the UK, France. Amazon's opened up research centers in France because they can fly better there. They can start doing deliveries. The FAA basically recognizes this. They fully expect that what's called the on-visual line of sight, which is not allowed under Part 107 without a waiver, will be part of a regular regulation. You can go fly beyond line of sight. And they fully expect that having multiple drones flown by a single person is going to be part of the regulation soon. All right, so I'll talk about that a little more later, but they're very much on top of this. And I meet occasionally with these regulators, mostly the people who are the kind of the field people who are looking at like our operations. They'll come out and observe our stuff, and we'll have some really interesting conversations. And they're very aware that they need to be pushing this stuff forward so the U.S. can stay competitive. So some things that they're doing to push it forward that have just been announced in the last few months. They have a controlled airspace committee, which is basically a committee that's going to come up with rules for you to much more easily get access to different types of airspace. Right now you can fly in G on a pretty much unrestricted basis, which is kind of most of the U.S. that's not around an airport, and it's below the high-flying people. But they're going to come up with better ways and processes to allow you to fly in different airspaces, because so much of the interesting parts of the U.S. around cities are near airports, right? So you have this constant process where you've got to check whether you're allowed to fly there, and if you are, you usually have to get a waiver to fly anywhere near an airport. I'll just leave it at that. But there's a process you go through. They're trying to make that easier, which is really important. The other thing they're doing is the drone identification committee, with the idea being that they want to be able to identify a drone flying in the air, and if they can figure out whose drone it is, then their ability to basically tell everybody you can do a lot of things like fly beyond line of sight, you can make deliveries, you can do a lot of these commercial applications that are almost allowed but not quite yet, will be allowed after they've come up with a standard for identification. Okay, that's very exciting, and they're expected within a few months to begin announcing how they're going to do that. The other thing that happened, so those were a couple of rulemaking committees that have been formed that show a clear direction. The other thing is that the new FAA authorization bill is in Congress. It hasn't been passed yet. We don't know what it's going to look like when it's done. But two of the more interesting parts are, one, that unmanned traffic management as an automated system. And I'll talk about VTOL a little more later, but there's this automated system where you can basically let your drone register itself for an airspace, say I'm going along this segment from point A to point B. Am I authorized to do that? Is the weather okay? Am I going to hit anybody? And the system, which is software running in the cloud, will basically talk to your drone and say, that's fine, go do it. And then you go fly it, and oh, there's a firefighter drone coming, you gotta land, wait, hover. The firefighter drone goes past, maybe a helicopter with a medevac goes past, and then you go back and complete your flight. So that's an automated system, it's mandated. We're part of the detect and avoid committee of that system that's being developed out of NASA. So that's really exciting. The other thing is that in that authorization bill and budget is a mandate that Congress has made to the FAA for them to issue a commercial delivery certificate. So you can get your drone equipped and authorized to do deliveries. That's the first time we've seen anything like that in any sort of legislation or regulation, that's going to be a part of the future of drone regulation in the U.S. Again, extremely exciting. So now obviously the likelihood is that there are going to be a lot of things you got to do with that type of drone to make it safe. before they're going to let you do that. But you'll be able to get it certified. We know obviously there are lobbyists involved in these things. We know that Amazon and Walmart, Google, and a lot of other people are very eager for this stuff to come to pass. And so the question is, can we get regulations that don't just benefit a few of those companies, that benefit all people who want to do deliveries? And I think that's likely. Okay. I'm going to talk quickly about safety and detect and avoid. This is really where our company focuses. So right now we have millions of drones entering the airspace, as I talked about, and we really don't have the ability to do detect and avoid, and we don't have a real way to integrate with air traffic control. Certain types of flights, you're supposed to call the tower and let them know you're doing it if you're flying with an airspace and then control, but that's pretty much it. So that's a real problem. So we have a solution that's exclusively licensed from NASA, includes the patent, includes the algorithms. It uses existing air traffic control infrastructure, which is a big deal because there are proposals to build entirely new infrastructure. So we really like that about our system, and it's really the first to market fully autonomous system to do this. So the problem is big, and it's getting a lot bigger. We've been watching it closely, 2014, 2015, 2016. The average number of incidents that get reported and published by the FAA, so that's a pretty high standard, that's a pretty high hurdle before it's going to actually get reported, is about 5.3 per day in the United States, and it's gone up 46% on average between years. It's likely to go up a lot more. These are situations where a pilot has reported that they've seen a drone and they've gotten to a point that they felt they needed to report it to the FAA. And so we know that there are many, many incidents that probably just nobody sees the drone or it doesn't get reported, but they're happening. So our system is designed to meet regulations with the FAA and to interact with the existing air traffic control system. There's a new fully automated air traffic control system called NextGen. Most commercial airplanes, passenger airplanes, cargo airplanes all already have NextGen transponders. It's a radio system. It's continuously broadcasting your identity, your position, your altitude, your direction, your speed. It's great for automated systems. It's great for air safety, and it is great for entrepreneurs to deliver new and better air services. And so we use that as one of our primary sensors, not the only thing that we use, but that's the new air traffic control system, and so we're obviously excited about that. A little bit more about our system. I'll just say that detect and avoid, which is what we talk about, is this idea of drones being able to see other aircraft when they're out of your line of sight and go around those aircraft. So that's the fundamental thing when we talk about detect and avoid. It's usually called DAA, and it's kind of the last gap. It's really the last hurdle to get over between doing visual line of sight flight of commercial drones to beyond visual line of sight drones. And the FAA has recognized that. It's basically mandating systems like ours as part of their strategy to allow beyond line of sight. So we work in what we call the systems segment of the market. You all are probably very familiar with this. You go out and buy a drone. You can buy the sensors, like some of the things I've talked about, and then you can buy systems for managing and delivering value with those things. And we're very much in the systems part of the industry. This is what our system looks like when it's installed. These pink devices are off the shelf, and we work with a variety of transponders and receivers. But these are the ones that we typically use, and this is a photo from a recent flight we did. We've got a high precision GPS unit, and we've got a transponder that's sending a signal out from the drone. We power that with a 9-volt battery, and we can see it for miles. Other aircraft can see us for miles, so it's a great solution. We have rechargeable 9-volts, and we just throw them on there. We have large battery packs we can use. They'll run for, I think we've gotten to run for about 10 hours at a time. So really easy to power this stuff and get great visibility. And then we have over here on the other side, we have a receiver. These are very inexpensive actually, and we use the very small ones sometimes. We can see up to 150 miles with these, and we can see all the aircraft in the airspace that have a transponder. And then that information is fed into our software, which is the Flight Horizon software, which runs there on the tablet. And we can see the airspace, and we can see all the other aircraft. And then our software is actually tracking and predicting where those aircraft are going to be and determining whether there's a potential conflict. And I'll show you a little bit more about that.
You mentioned high precision. What level we are talking about?
So it's within the range of the ADS-B protocol, so it's either 25 feet or 100 feet for altitude, and then for horizontal space, it varies. So, but yeah, Yeah, they're different settings. You can configure them to do different things. But they're intended mostly for avoidance purposes, so it's not like centimeters. We wish it were, actually. We do use some things that go down to like centimeters. But the protocols themselves that are used by air traffic control only go down to 25 or 100 feet. So the way this system works, and that's relevant to this, is you put this transponder on your aircraft, and it sends a signal out that's visible to other aircraft and also to the air traffic control towers. So they're actually what are called ADS-B towers that the FAA runs throughout the U.S. And that way air traffic control can see you, other aircraft can see you, and then importantly for us, our software can see you, and our software can track where you are and where all the other aircraft around you, and do this prediction process of deciding whether there's any chance of a conflict, and then keeping you out of that conflict. If you're using the interface, which I'll show you here in a moment, it's going to tell the pilot, you need to do this right now. It basically starts yelling at you. And that's really what it comes down to, is it gives you a visual warning, an audible warning, and it shows you a path that you need to take to get out of that conflict and self-separate.
Imagine a world in which drones travel freely throughout the U.S., inspecting vital bridges and pipelines, responding to emergencies, and delivering packages safely and efficiently. That future is just over the horizon, but one of the last remaining barriers for safe and legal integration into the national airspace is for drones to be able to automatically detect, track, and avoid other aircraft. Vigilant Aerospace overcomes this final barrier with our Flight Horizon system. Flight Horizon is flight safety software based on an exclusively licensed NASA patent and prototype. It provides the logic and algorithms to detect and track other aircraft using a variety of sensors and to issue an avoidance command to an unmanned pilot or autopilot to prevent potential collisions. When used by a pilot, the software provides a visual map of the aircraft's location relative to other nearby aircraft around it for tens of miles and provides traffic alerts and collision warnings. If another aircraft gets close to the drone, the software immediately alerts the operator with a visual and audible notification, and if a conflict is predicted, the software sounds an alarm and issues a specific command to avoid the collision. Once well clear, the operator is given instructions to get the drone back onto its original flight path. Flight Horizon also provides a 3D model of the drone and the aircraft around it, giving the operator a synthetic cockpit view. Waypoints can be entered to direct navigation of the drone, and all flights and encounters with other aircraft are automatically logged by the software. Flight Horizon can also provide weather radar data, control zones, and navigational charts, as well as high-resolution aerial photography of the ground. During recent beyond visual line of sight tests at NASA Armstrong Flight Research Center, the system was used to complete 18 encounter scenarios over nearly 100 flights, and successfully detected and tracked 100% of the air traffic and warned of all potential collisions. The tests were monitored by staff from the FAA and the FCC, and all flight data was collected and analyzed by NASA and Vigilant Aerospace. Flight Horizon provides commercial drone operators with a complete flight safety and compliance solution for beyond visual line of sight flying and the future of commercial unmanned flight. For more information and to sign up for a demonstration, go to our website at www.vigilantaerospace.com, and also be sure to sign up for our newsletter and to follow us on Twitter at VigilantAero.
All right, give you a little bit of an idea of how it works. We're constantly revising that video, which I constantly get to re-narrate in a very unprofessional way. But we do add things to it over time, so we can talk a little bit more about what we've done. I won't go into this a lot. We just have a few minutes left. I want to make sure that I leave a little bit of time to talk about future trends and answering questions. But this is a little bit about how our system works. It's constantly looking at the airspace, indexing the targets, determining and predicting where those targets are going to be, deciding whether an avoidance strategy is needed, picking one, issuing the commands, and then remonitoring. And it's doing that on a sub-second basis. So it's many times a second, it's looking at all this information. It can look at the information a lot faster than the airspace can actually give it the information. So as we add radars and other things, so we are adding micro radars, either ground-based or on the aircraft, that precision goes up quite a bit, so we can look at the airspace on a sub-second basis. So we're really excited about that. The transponders are sending out usually a transponder about 5 times a second. is supposed to send that information out in order for you to be able to find where other aircraft are. You can imagine you get 10 or 15 aircraft in aerospace, which we certainly see sometimes, and you've got thousands of messages on top of you in moments, which is actually really good because you can use all that information to figure out exactly what's going on with those aircraft. It's really good for error correction as well. We've gotten a lot of industry press with this product, which has resulted in a lot of people approaching us. We're working on a cloud-based system so that it grabs your flight logs, because it's continuously logging the airspace, and a lot of people really like our system because of that, and upload it so you can recreate all of your flights. So CNN, for example, is an organization that could use that because they do a lot of flights in a lot of different places, and they want to be able to, for example, look at where all the people flew and when they flew and what happened. Real quickly, I'll just talk about this. This was a client that does offshore marine patrol. They work for local sheriff's offices that are doing a variety of different types of search and rescue and public safety. And they were flying, they fly this system, which is one of these hybrid VTOLs that can take off and then fly for hours and come back and land. It can take off anywhere. It's a great system. And so we're working with them on public safety, on making their flight viable for going to the line site. That's really why we're working with them and why we're talking with them and consulting with them on their waivers. So they're in a high-density airspace. They're near an airport, so our system is especially valuable. They currently do what's called extended visual line of sight, so they have boats or other airplanes giving them updates on where their aircraft is, because they have to have somebody with eyes on that aircraft, and that's very cumbersome. So that's where that's going. So we recently did this patrol with them offshore, and it was a great validation for what we did. So I've just got another couple of slides here. Emerging trends right now. We talked about beyond visual line of sight. I think that's going to come really soon. Flights over people. That's also going to be rules about how and when you can do that. Delivery is coming really soon. Multi-aircraft flights. There are already several waivers out there for people to be able to fly 20 aircraft with one pilot. There are restrictions on how and when they can do that. Mostly doing it in the desert, for example. But they're able to do that. And in fact, there's a real interesting thing with the regulatory regimen right now, in that you can have a car that is multiple tons, traveling tens of miles per hour around other people that can drive autonomously, according to the laws in a lot of states. But you can't have a drone do the same thing over a cornfield in Iowa, a small drone. You're not allowed to do that if it's not within your visual line of sight. And so it's this real risk ratio discrepancy between the way that ground vehicles are being regulated right now and what's allowed, which looks very dangerous to me. And I think it's going to be great. I think it's going to be viable, but it has a much higher danger profile than me flying my drone beyond line of sight over a cornfield somewhere, which is absolutely illegal. So it's a very interesting thing. People are beginning to realize that, and that's emerging as a theme that people understand. We need to be able to fly unmanned aircraft much more freely than we can now. Full autonomy is really critical for a lot of the economic use cases. If you're doing pipeline inspection, you really need multiple aircraft to do that, and you need to have one person be able to watch those aircraft. They're in a rural area, they're flying over a right-of-way that's already established. So lots of interesting emerging trends. Onboard sensors, these are coming really fast. Just in the past 2 years, we've seen massive developments with this. They've gone from units that are kind of like this down to units that are kind of like this, and they're going to be about like that, and you're going to be able to put a radar that can see far enough to see other fast-moving aircraft onto your drone. I mean, that's happening. We're talking with a couple of companies about getting those into our system. And we're really excited because we want to have radars. We have ADS-B, which is these transponder signals, and then the UTM network. We consider the UTM, which is the automated air traffic control system, great for last mile flying where you're in cities. You have 4G, 5G cellular network, which is really what's required. So you would turn off your transponder, you would turn on your UTM system. So we think that's the future. So we're a partner in that program. All right, let's blaze through the last bit of that, and I now have time for questions. Yeah.
To deliver drones, does this mean we're going to have to retrofit buildings to actually have just a landing pad for drones? I mean, how's that going to work? I don't know.
Yeah, I mean, I don't know exactly. The drones that have been proposed and the basic amount of information that companies that are trying to do it have released indicate that they expect those drones to be able to land almost anywhere. With the idea being that they're going to have very detailed maps of where they want to land, where they think it's safe to land, where the FAA maybe has authorized them to land. And so that's where they would land that drone. It's the only place they'd probably be allowed to land. And it's likely to be on top of a building or a backyard, or maybe even down the block, there's your drone depot for your block, right? I could easily see those things happening. Because the advantage is so huge to be able to have essentially same-day autonomous delivery of something. We're talking with some companies that are working on those projects, and so they're working really hard to make all that work. Yeah.
Do you foresee a time when detection and avoid systems will be required on drones? Or is that's way down the line?
So for beyond line of sight, they are required. If you're going to do beyond line of sight, some form of detect and avoid is required. What that typically means right now for the very few entities that can do beyond line of sight is they have some form of observation of the airspace. So they probably have one of these transponders. They may have it on their screen. They don't have the types of warnings. They don't have any autonomy around it, so it doesn't talk to an autopilot. It's not doing anything for them. It just tells them, hey, there's an aircraft somewhere. Okay? And usually, honestly, talking to a lot of pilots about this, it doesn't even tell them. If they happen to look at the screen at the right time, they'll see that there's another aircraft coming, and that's the best they get. And so that's actually why a lot of people are talking with us, is our system goes several steps beyond that. But the regulations now are that if you're going to be beyond line of sight, if you're even going to apply for it or talk to the FAA about it, you must have a detect and avoid system. So we're not the only detect and avoid system. We stand on the shoulders of NASA with this system where they have spent millions of dollars developing the avoidance logic, right? Which most companies that are kind of in our space that are talking about detect and avoid haven't done. And it's just because they're focused on the sensors and they're focused on piloted unmanned aircraft, whereas we're looking forward to the next generation, which we really think is the only economically viable generation path of UAS systems, which are fully autonomous. We've got one person who's watching 5 drones do a pipeline inspection, for example. They're going to those drones are going to need to be able to do avoidance. Like doing the Marine Offshore Patrol, one of the things that's interesting is that company is extremely interested in full integration of their autopilot. Even though they have highly trained ex-military pilots on all their stuff, they're worried about when that aircraft loses signal for whatever reason. So that if they've got the aircraft out there and it's in a busy airspace, they want the assurance that it's going to avoid other aircraft even if they can't talk to it. And so that's really where everything's going, is towards full autonomy. The other thing is if you talk to people who are trying to integrate drones into public sector, public safety, they don't really want their firefighters and sheriffs and policemen and rangers joysticking around, which is kind of what it gets called. They don't want those people piloting these aircraft. They want the safety systems and the autonomy systems to be sufficient that they can buy the aircraft, they can learn how to use the software. And the reason is because that they know statistically human error is going to be the greatest source of error with a lot of these things. If it's flying within the rules and it's fully autonomous, generally the accident rates are really, really, really low. As long as you have a lot of controlled conditions. So, I mean, if you're flying in areas where you have a specific mission, whether it's forestry or in the desert or offshore or along a right-of-way, your ability for the robot essentially to be your safest option is very high.
Do y'all have any partnerships with academic or university partners in terms of research or training?
We are talking to people about that, so we're very interested in that. We have a very strong partnership with NASA, and NASA Armstrong particularly, and of course they are a research organization. So we work very closely with them. They're actually using this software in NASA operations at multiple centers, which we're really excited about because we piggyback on that and get massive amounts of data. But the answer is, yeah, we'd like to talk to people. And then training is a whole other thing. If you go to our website, we actually have a page about education partnerships.
We'd like to talk to you.
We'd love to talk to you. Yeah, absolutely.